What are radicals? Radicals are intermediates with an unpaired electron. Some examples of radicals include hydrogen radical, chlorine radical, and methyl radical. They are often called free radicals, and they are formed by homolytic bond cleavage. Radicals are highly reactive and short-lived species. Half-headed arrows are used to show movement of single electrons. The stabilities of carbon radicals follows the same trend as for carbocations. The more substituted radical is the more stable. Radicals are electron deficient, as are carbocations, and are therefore also stabilized by hyperconjugation. Just like carbocations, tertiary is more stable than secondary, more stable than primary, and more stable than methyl radicals. The reaction mechanism for radicals have three different parts. First is initiation, then comes propagation, then comes termination. Initiation produces your radicals. Propagation can have two steps, propagation 1 and propagation 2. Termination uses two radicals to terminate. Now let's apply what we learned. So here we have propane reacting with Br2 and heat to get your final product. As you can see, homolytic bond cleavage is occurring to give you your bromine radicals. This is the initiation step.
Now that we have the bromine radical, we can move on to the propagation step. In propagation 1, since the bromine radical is very selective, it will attach to the hydrogen of the most stable carbon. In this case, will be the second carbon. We use half arrows for the radical reaction to indicate that only half of the electron pair is taken from the bond between the hydrogen and the carbon. The products for this step will be secondary carbon radical and HBr. In propagation 2, the carbon radical that was just created will react with Br2. We also use half arrows. The first arrow will attach the carbon radical to form 2-bromopropane. The second arrow will go to the other bromine to create another bromine radical. This bromine radical will go back to the propagation 1 to react with more propane and make more products.
As we have looked at the steps for the radical halogenation of alkane, we have seen initiation and propagation 1 and 2. The very last step in this reaction is termination. It is important to perform this step or the reaction will continue indefinitely, leaving undesired results. During termination, the two radicals will react with one another using half arrows and produce a stable diatomic R group molecule. Something to remember is that a lot of students commonly mistake, but the two radicals should only react during the termination step, not during propagation, because it will stop the reaction.